All right, so welcome. I'm going to give you a little journey through your dog and other dogs that you see in the world. We did title it "What Your Dog Sees When They Look at You." I will add the caveat. What's that? Oh, lights. Yes, let's put some lights down. Let's see, light controls. Gosh, front, dimming, low. Oh, blimey. Okay, maybe not. Medium. That's medium. Board. Oh, okay, that works, right? Okay, perfect. Okay, so welcome. I did add the caveat at the end here that it's not just when they look at you, it's other things as well, because they sadly don't just look at you, they look at many other things as well. So welcome. I wanted to give you a quick primer because I guess you can already tell I'm not from here. So these are some representative cultural references that you should all ingrain in your memory as part of who I am. So I grew up in the part of the world that grew Wordsworth and Peter Rabbit. Hadrian's Wall is to the top left. I grew up in the English Lakes, and then if anyone knows, is a hiker, they know about Romney's Kendal mint cake. I actually went to school in Kendal. It is one of the most disgusting confectionery items you will ever eat, but if you are curious, you can look it up. It is truly awful. So also to give you a bio of my story, so I actually went to vet school in the University of Bristol in the UK, and then actually fell in love with farm animals because of where I grew up in the UK. But I slowly over time, and I could tell you a long story about why, but decided that I wanted to go into ophthalmology and into research. So I did a PhD at the University College London, Institute of Ophthalmology in London. And then I became a Spartan, so go green, if anyone's part of that community. So I did my postdoc and residency training in veterinary ophthalmology at Michigan State University with the wonderful Simon Peterson Jones. Then I took a brief foray down south. So I was at NC State for a few years before becoming a Badger. So I've been a Badger since 2020, a bad year to move careers, but it was a good journey and a very sort of positive experience. So I obligatory have to show you this. I did do this as a veterinary professional. So I was actually mostly large animal when I started. So that's your classic James Terrier. I was that person for a few years. I moved on to the front part of the animal quite quickly. So this is me as a resident looking at a giraffe retina, and it's being fed Ritz crackers while I do my exam. So bribery always wins. And then this is me. This you might think is a wolf. This is a descendant, a dog. This is a wolf. So our dogs are descendants of these. This is one of the native wolf species in the US, or the only native species of wolf in the US, called the red wolf. And I did some research when I was at NC State on diseases of the eye in red wolves. And this is me. I couldn't have a presentation about Mary without sort of showing me as a Mary member. So this is members of my lab a few years ago. This is my own dog, Tavish, who is now more than a potato with legs, but he's very sweet and very happy to be a member too. So we do a dog walk every year. So Cycle for Sight, we actually do dog walk for sight to try and kind of bring awareness to vision research. So this is Josie. She belonged to one of my residents, or probably still does, at NC State. So this is your dog looking at you, right? So they lock eyes with you. They have evolved. This is pretty much how they got domesticated, right? Is to look at you in the eyes and ask for food. So this is what you see, but what do they see? So this is us. This is an agility course. If you're in agility, you're familiar with the sort of obstacles here. We've got a teeter, we've got a jump and a tunnel. And this is you looking at that obstacle course. And so what you see is that each individual eye has about 170-degree field of view on each eye, but you've got a large area where both eyes are capable of seeing the same image. That's called binocular overlap, and that gives you the detailed perspective-based, you can tell that something's 3D by using that binocularity, that double eye vision. If you think about your dog actually, each individual eye has about the same amount of view, so 150 degrees, but if you see, it's actually spread over a wider area. So that means that your dog has better vision behind their head. So it means when you drop the leash, they can tell. But what you can see is that in most dogs, that little area of binocularity, that double crossover vision is smaller. I wish that they had put a little bit more thought into this view, because the other thing I want to remind you here is that dogs don't fly at the same height as us in space, right? They're a lot lower down. So if this dog was looking at this tunnel would be a lot bigger, this jump would be a lot bigger. So their perspective is also different. So you have to think a little bit less anthropomorphic about what your dog sees, not only from the perspective standpoint where they are in space, but also in terms of how much they're able to use their binocularity. So if that dog wants to jump that jump, it's going to have to use that small field of binocularity to be able to tell where the jump is in space so it can actually jump it effectively. So don't judge your dog so much for knocking bars if you're an agility person or something like that. So I took this a little further, and they're descendants of wolves, but we have made them into what we want them to be, right? So we've got a pug on the left-hand side, we've got a greyhound on the right-hand side. We've created dogs for our purpose, some of which is companionship, and most of which is companionship. So I kind of want to just point out that perhaps that binocular overlap is different between different breeds of dog, and it's something I'm very interested in. I've not published this paper yet, but we've actually shown that dogs with that smush face actually have a wider perspective. Probably means their binocularity is less. So if your pug misses the treat on the floor, you might start to think maybe their binocularity is impaired by us creating them. I also did an objective literature search on pixabay.com, which is an open source, and these are the pictures that came up. So just we've bred them for purpose. Purpose is entertainment for the most part for pugs, which I think pugs are dear and delightful. And then this was a similar literature search from Pixabay on greyhounds. So you can see that, you know, they're still kind of doing their job, although occasionally we do dress them up as well. So one thing that people ask me a lot is, why does my dog's eyes shine at night? And so what is that? Why do, if you catch a deer in the headlights, if you see your dog with a flashlight, why is there that reflective appearance to the eyes? And that's the structure called the tapetum lucidum. And it's essentially an adaptation of the eye to dim light environments. So we've actually, multiple species have done this, and they've essentially created a reflector at the back of the eye behind the photoreceptors, so that when light goes through, it hits the photoreceptors once, and then it bounces back off and it hits the photoreceptors a second time, and it gives them an extra level of sensitivity to light. So if we look at the back of the eye in our ophthalmoscopes, and hopefully some of you will get to see at least a little view of this when we do the demo, but this is what you see at the back of your dog's eye. I just think it's the most beautiful thing in the world. Each dog has a unique kind of color, so we get all the way from sort of pinks to blues in puppies, and then all the way to sort of greens and yellows, so it's just a beautiful kind of reflector at the back. And what you can see here is this is the blind spot of the eye, this is the optic nerve, so that's the area that transmits the information from the retina to the brain, very important. And then there are blood vessels that kind of creep up through the retina to give the blood supply to the retina. And then if we chop the eye in half and we do some histology, this little green streak at the bottom of that right-hand image, that is your tapetum lucidum. And here are the photoreceptors sitting right next to that tapetum. So you can imagine light comes from this direction, from the top to the bottom, hits the photoreceptors once, bounces off the reflector at the back of the eye, and then hits those photoreceptors again. So you've really got an amazing ability. Your dog can likely see a lot better in the dim light than you can. Just to point out one anatomic variation here that dogs have, hopefully you can appreciate that these vessels don't kind of uniformly cross all over the retina. There's kind of an area along the horizontal meridian here that is devoid of vessels, does not have vessels in it. And we'll kind of come on to that in the next couple of slides. So I just wanted to point it out. So if you are interested, this is what your ophthalmologist sees when you go to the eye doctor. So same kind of anatomy, just slightly different. So this is the optic nerve. This is the blind spot of the eye where the information goes to the brain. We also have blood vessels that kind of curve around and avoid a region of the retina. This is the macula. If you have older family members who have macular degeneration, you'll know about this region. It is the region that contains the highest concentration of photoreceptors in your eye, called the fovea centralis. And so this is the region you use to read, the region you use to drive or do anything very high acuity or high quality vision. And although dogs don't have a fovea, so there's no region equivalent to that where it's kind of creeping around a central area, they actually have something called a visual streak, which is essentially the equivalent for a dog. They have to scan the horizon for predators or prey or mates. And so they've evolved this more streak-like structure. And then within that, they have one region called the area centralis, which is just a little bit better than the streak itself. It's not quite a fovea. It's kind of close to a fovea, but not quite. But the dog has something kind of not too dissimilar to us in terms of high quality vision. So this is work that I did on the left-hand side when I was a graduate student. I begged my PI to let me do this research on my spare time because my project was not in dogs. And so this is a heat map of the photoreceptor density, the cone, the color photoreceptors in the retina of the dog. So the blue spot in the middle here is the optic nerve. And then here is our visual streak, the denser region along the top of the optic nerve. And here is the area centralis, so the denser area of photoreceptors next to the optic nerve. Similar in people, so the black spot here is the optic nerve. Here is the fovea centralis. So you can see it's kind of glowing red hot. That's because there are way more photoreceptors, cone photoreceptors in the human fovea than there are in the dog area centralis. But you can kind of see some parallels here. They're not so dissimilar to us that they're an alien species. So stare at this for a hot second. Hopefully someone can shout out to me what number is written on the screen. 74, all right. There may be, based on the number of people in this room, a couple of people who cannot tell that there is a number written on the screen. That is because this is a red-green colorblind test. So it's the number 74 in green, and then around it are lots of red colored dots. And so if you are red-green colorblind, about 8% of men are red-green colorblind, and about 0.4% of women are red-green colorblind. And almost all of your dogs are red-green colorblind. So this is what your dog sees. So I would have a hard time saying that was 74. So just bear in mind that if you have toys that look the same, look different to you, but are perhaps in the red and green spectrum, your dog may not be able to differentiate those two. And it always kind of makes me pause a little bit about what my dog sees versus what we see. So this is a real world scenario. This is me. I went to the Grand Canyon back in December, and I was really struck by the redness of the walls and then the green of the kind of vegetation. And I was very interested to think about how my dog might see that. And it's not as rich, right? This is, if you are curious, you can actually feed your own pictures into that website, and it will tell you what your dog sees. So if you want to pick a toy, take a picture of it, upload it, and see whether that is something that your dog could see well. And this is what your dog sees. So color is obviously a lot more dilute in kind of contrast. You've also got some acuity differences. The quality of that vision is different compared with your own. So dogs are definitely not quite as detailed in their ability to see crisp images than we are. So when we kind of come back to color a little bit, this made me smile when I was a graduate student to kind of think about, but this is a picture that was taken from the Seeing Eye organization here in the US. This is a service dog organization that trains and breeds service animals for the general population. And this is actually a trainer who is training someone to train the dog. So this is not a visually impaired human, this is the dog being trained. So you can see the trainer, you can see the person training the dog, and they're just essentially training the dog where to walk, how to navigate. But what makes me laugh is that in the UK, and this is obviously a little different here in the US, the crossing signals for a human, so this is you standing with the walk, don't walk sign in front of you, the crossing signals, it's red for stop, and it's green for go, right? And so actually, if you then do that from the dog's perspective, the only reason that that dog knows really whether it's stop or go is the position of the light rather than the color of the light. So we have created kind of some challenges for our working dogs by putting red and green a lot in our stop and go scenarios. So when you go to the eye doctor, you're going to read an eye chart very similar to this. These numbers on the side tell you how good your vision is, and you're aiming for a 20/20. That means that your vision is crisp and perfect, and you can read this line of letters from a certain distance. We don't have the same equivalent for dogs. I thought this picture was wonderful. So we do not do this in the clinic. Wouldn't it be wonderful if we could have them sort of look at butts and tell us which one they could see? So this has been something that sort of made me think a little bit, because our ability to test vision in dogs is just really not good. So this is how we test vision in our patients, which is very embarrassing and a little bit sad. So we wave our hands at their face, and we ask if they can blink because they don't want to get hit in the face. We don't actually hit them in the face. They've learned that something coming towards their face is potentially a risky thing, so they blink. So I'll just play that one again. So we wave our hands in the face, we check they can blink, and then we wave their hands and they blink because they think we're going to hit them in the face. And then when we look at a visually impaired dog, this is a dog, as you can see, that has some cataract in that eye. It's actually just had some surgery in the other eye to remove that eye. And you can see that when we wave our hands at this eye, there's really nothing that happens, right? So that dog is not blinking when we put our hand to the face. So this sort of makes me cringe, especially when I present to human ophthalmologists, because it's just so crude. So if we think about that hand waving maneuver and we compare it with the eye chart and we scale that eye chart way down, so 20/20 is down here at number 8, 20/20,000 is the equivalent. So we're essentially saying, is the dog completely blind, or is it able to see a little tiny bit? And so it's a really, really not great way of testing vision. So this has been a long odyssey, and Michelle, who's in the audience, can tell me how long an odyssey this has been, to try and figure out if there are better ways for us as researchers or clinicians to assess dog vision. So this is human ophthalmology taken down to the child level, right? Children are not too dissimilar to babies, to dogs, sorry. And so what we do here is this is called a teller acuity card, and essentially this has a tiny peephole in it, so it's not just some person holding in front a card, but they hold the card, they wiggle the card a little bit, and the baby in theory looks at the more interesting thing in the space, and that is this grating, this like vertical bars, and you can change the grating intensity, the amount of grating size, and that can tell you how well a child sees. So it's you kind of go back and forth between able to see, not able to see, and you can kind of hone in on where a child might fall in that acuity chart. So nonverbal children have to be tested in that different way. So my grand idea was to do this in dogs. Yeah, totally. So this is Prada. This is Michelle. So yeah, she got to volunteer. So this is us doing a kind of equivalent to this. And Prada's like, oh, that's kind of cool. Okay, I'll look at that. We made it move because we figured it might be more entertaining that way. And we do it again, and she kind of gives a side eye. She's like, okay, I guess I'll look over there. And then the third time around, when it goes, she's yawning. She's probably a little worried, but she heard a noise. I think we played a little squeaky noise or something, get her attention back. Then we did it a third time, and she barely looks, right? So 3 attempts, and we've already got the dogs bored, right? So we couldn't do this test repetitively to hone in on where the dogs might go, be able to see, because we couldn't test it for long enough to keep the dog's attention. So we tried it with a few dogs. We tried training the dogs, and of course you can't always teach dogs well to do things that they're not motivated to do. So really it just, you see she pretty much checks out. She's not interested, and she was one of our top performers, I will tell you. So this was a whole summer of trying to do this and failing miserably. So what had grabbed my attention around the same sort of time was that some people talk about their dogs watching television, right? So much as this was a Guardian newspaper story about how her dog thought that dog TV was really boring, but actually some dogs do watch. So we actually devised a questionnaire for dog owners, and we asked them, what does your dog like to watch on TV? And this was because we wanted to design a test that's salient and relevant to dogs. So I got a lot of press attention because obviously it's a fun subject. I got interviewed by The Guardian, various other news outlets, and it's kind of a fun subject, but it's also meaningful to me as a researcher. So this is Seymour. This is one of my colleagues' dogs, and he purposefully put puppies on the screen for Seymour to look at. Seymour has some opinions about the puppies. But yes, so that's a classic kind of subject area. This is more of a fun one. So this is a herding breed. This is Pete, the border collie, and he's watching another border collie do herding. But what's really fun is I think Pete cares as much about the sheep as he does about the other dog. He's actually dividing his attention between the sheep and the human, and the dog occasionally flicks back to the dog. So there's some really interesting visual motivations here, right? There's, what do you care about most? What's the most salient in this environment? Is it the human? Is it the dog? Is it the sheep? So we asked some questions. What's the most interesting to dogs? Not surprisingly, dogs like to watch dogs. I don't know if you're all dog owners, but my dog stares at dogs all the time. So he doesn't know if they're real or not, maybe on the TV, but they certainly want to look at dogs the most. Animals ranked the highest in our preference, but dogs by far were the most popular. Then wild animals, cats, livestock, horses. You can see humans did not make it to the top of the list. They made it about halfway down the animal list, I think. So they really weren't very popular. I think their preferred humans, obviously irrelevant, but not humans in the real world, like in the virtual world. What was interesting is the next best category for dogs was cartoons or other categories. So it was really interesting. I guess what we designed for babies is also potentially interesting to some dogs as well. Not all dogs, but perhaps some. Balls. We've got a lot of retrievers in our world and they love balls. So ball sports were very popular, basketball and soccer being the most popular. Vehicles, some dogs like to chase cars, but not terribly popular amongst dogs. And then non-ball sports, if you notice, it's the non-ball sports that involve animals again. So animals are by far the most salient popular thing. And it doesn't mean that all dogs watch TV. It means that those that do like to watch animals. So we are interested in aging. This is one of my main research interests. So I started to look at whether age relates to whether a dog likes to watch TV. So this is all of our respondents and the age of the dog on the x-axis. And so what you can see is the most common age for dogs to watch was 1 year old. So it's a young dog thing. And it's a curious kind of behavioral question. Is that because dogs just realize it's not real over time, or is it because their vision gets different? Who knows? We'll find out at some point. I did have a few people who said, no, my dog just doesn't watch. We didn't specifically ask for those people, but they answered the questionnaire. And what's interesting is the dogs that don't watch, their most common age is actually 4 years old. So there's some thought there that maybe dogs really just lose their interest in watching TV as they age. So just to touch on behavior and relevance for our dogs and how healthy it might be, I think we have to think about what dogs do when they look at television. We sit and we relax, we enjoy the storyline, we're kind of engaged. Dogs actually get excited. They approach the screen, they want to go interact, they want to do the things. Some of them run away from the screen if it's worrying. So I think we have to be careful that some of these behaviors that we're seeing might not be the most healthy for our animals if they're left alone. If we asked the owners to describe what behaviors their dogs did in kind of a free-form way, they gave us more active verbs, moving, reacting, doing things, than passive verbs like we would do, like lying and sleeping and sitting. So I think it's just a different experience for them than it is for us. And then many people that answered this questionnaire do provide this as entertainment. So 50% of people left the TV on for their dogs, and then 15% exclusively provided TV rather than other enrichment for their dogs. And then most people present kind of YouTube-ish type videos rather than some that actually do the sort of proper dog-specific content. And we don't have any real knowledge on whether that dog-specific content is actually good for them. So I think it's a place we need to do more work. So I put this in. Oh, I didn't realize it's going to have a beep. So you are all used to that old-fashioned cinema screen flickering kind of view, right? Back in the day, we kind of see it now in old movies. That's what your dog sees for the most part when they watch TV, because our screens are not designed for the dog's visual kind of system. So what we see is really smooth, kind of moving images. Our dog only sees that when they watch high resolution TV. So it's just important to know what we're presenting to our dogs. So I just wanted to kind of give you a tiny, right near the end here, a tiny little vignette into the animal kingdom. So in terms of the ability to see flickering images as they're presented, kind of like that movie screen, our insects have the best ability to detect. So they're essentially in real life seeing that flickering image as it goes along, because their fusion, their ability to see a smooth image is right around sort of 160 cycles per second, which is really the highest resolution TVs that you can get these days. If we then go down to the next best type of species, we're talking about birds. So many birds of prey. They have, again, pretty high flicker fusion frequencies. So their world is, if they're watching TV, is still kind of a set of single images rather than a smooth image. Dogs rank next. So actually dogs are pretty good in the animal kingdom at being able to see those individual moving images. Us and cats are about the same. So it's kind of funny that actually cats, we get a lot of people that tell us cats like to watch TV. I wonder if it's because they and us share the same space in terms of ability to see those as a single smooth moving image. Because I don't know about you, but I don't like watching those old movies because it's kind of like a sort of flickering kind of image to my mind. So our dogs are probably seeing that flickering when we are not. And then if you go down kind of towards the less capable, the mice and the rodents, and then the insects. So I just wanted to put on here the lines. This is our regular TV flickering. So 60 hertz is a typical kind of regular TV. And then the high resolution TVs are usually around 120 hertz. So what you can see is that we can watch either of them because our fusion is kind of in the 60 hertz range, whereas dogs see those flickering images. So just be mindful of the fact that if your dog doesn't like watching TV, it might be because you need to upgrade your telly. So we do present videos to dogs in the lab. This is me doing science with dogs, which I just think is amazing. So this is a very enthusiastic golden retriever. We flipped the view. This is the view of the dog, and then this is what they're looking at. And we flipped it so it looks like it's tracking the right way. And so as you can see, this dog is highly engaged in watching this subject move along the screen. So we have a couple of different tests that we're starting to work with to try and assess whether we can tell what dogs are able to see using tracking of meaningful images, so mostly dogs, as you can probably imagine, in the lab. So the last thing I just want to talk to you about is aging. We are all aging as we speak, and there's lots of ways that the eye and the visual system can age. So the first thing is you probably need to wear glasses as you age because your optics change. So your lens changes, your cornea changes. You can also get changes in the back of the eye, so that retina can either get diseased or it can get age-related degeneration or signal transduction changes. And then finally, the other part that we have to think about is how that brain is receiving and processing the information. So it's an interesting subject area because there's so many pieces to aging of the visual system. When we think about what we struggle with the most as we age, we actually think mostly not about daytime vision. We actually think about reading a menu at night in a dimly lit restaurant. We think about crossing the street at night. Those are the hardest pieces for our vision as we age. There's lots of reasons for that, which include all of those 3 different areas I just mentioned. But it's important then to be able to ask relevant questions from our animals to ask whether that is also the case in our animals. And so we designed another owner questionnaire, and you guys are awesome. You can tell us things that we wanted to know. So this is us asking dog behavior questions relevant to bright light settings. So when you take your dog out for a walk during the day, what do they do? And then we form kind of a number system that grades that response. And what you can see if dog age is on the x-axis here is that there is some decline in that visual ability, even in bright light, in dogs as they age. But what you see is that there is more amount of visual dysfunction in older dogs and even in dogs in general when we take our dogs out to walk at night. So there is likely some effect of aging on the visual system very similar to people. And when we sort of put some math to it, we can say that the average age of onset would be predicted in dogs to be about 4 years in the bright light setting and about 2.5 years in the dim light setting. So that suggests that that vision dysfunction in dim light is actually onsetting earlier than it is in the bright light setting. So you're probably a little bit blinded by science, but there's some take-home messages I'd love you to know. So your dog's vision is different, but it is similar. It's kind of awesome. So the key differences are that they have a different field of view perspective. They have different color perception to us. Their resolution or acuity to see is different. And they see flickering images on screens more than you do. So their fusion frequency is different. We as veterinarians and researchers need better ways to test vision in dogs. This is my goal as a researcher in the next few years, to prove that we can do this in a better way, both for our patients and for our study participants. And then aging affects our vision and our dog's vision in similar ways. So this is my research program. I'm very interested in studying aging of the dog's visual system because they are our little sentinels. They sit by our sides. They eat our food quite a lot. They certainly drink our water. They walk out into the world with us. So in theory, if their vision is impacted, we might be able to find reasons why their vision is impacted, which could have an influence on our ability to see as we age as well. So there's a lot of people to thank. It's a broader picture discussion, but there are lots of people in my lab and lots of dogs that come to visit us. This is just a small subset of the dog participants that have been in my research studies. Huge kudos to Michelle, who's here today. This is also Cassie, our research technician and one of our very happy participants. We give them a ball to take home, and they're all very joyful about that. We do have lots of funding sources to thank, including the National Institutes of Health. And if you are curious about ongoing research and publications in the lab, we try and put all of our papers free of charge. And if you ever want a paper, you can always email me and I will give it to you for free. So, any questions or comments? Question over here. Jonathan's coming with a mic. I think there's a mic coming for you. There you go.
What can we do as dog owners to protect our dog's vision?
That's a great question. I mean, I think what healthy lifestyle choices you make probably also have some influence on your dog. So maintaining healthy weight, a good diet, just varied diet in terms of, a good quality diet with good antioxidants and things like that. There are aging diets now available for dogs. I think there's some research going into those as well. So I think it's an emerging field. Gerontology is actually not a veterinary specialty at this point. So we're just really piecing things together in terms of how to support our dogs as they age, because just like our lifespan has gotten longer, our dogs' lifespans have also got longer. So I think making healthy choices for yourself, making healthy choices for your dog. Dogs will get more dry as they age. So we'll often tell our older dog owners to put a little bit of lubricating drop into their dog's eyes to just keep them healthy. We see a lot of clinical disease of the front of the eye, the cornea, in our clinic. And we always like to avoid that if we can, rather than having to treat an infection. So yeah, a little bit of, healthy choices and maybe some lubrication for the corneas would be a good couple of choices. Mm-hmm. Question over here.
Thank you for the wonderful talk. So I have just curious about how broad the spectrum range the dog can see compared to human. So for human, we can see from 330 or 400 nanometer to 780, right? So we can see a little bit near infrared, but how the dog can
there's
see.
actually research. There was a military-funded study because I think the DoD probably thinks that's very interesting, right? If dogs could see where we can't, there is some vision in the UV spectrum in dogs. It is not clear how functional that is for dogs, but yes, I think there could be some more knowledge coming in that space. But yeah, I agree. I think their spectrum may be very shifted compared to ours. Yep, good question. A little bit broader, I think. Maybe shifted over to the UV side. I think their blue is good. So then if we shift into the UV, maybe they shift away from some of the other side.
And dogs get a lot of the same things that us as human ophthalmologists we see in human patients as well too. Do you have a comment with regard to breeds, mutts versus purebreds, in terms of how folks should be surveilling their dogs' visions? Which ones are more at risk?
Sure. Yeah, so the question was just, are there any breeds that get cataracts or eye diseases more commonly? Purebred dogs have, we've line bred our purebred dogs to make them functional for us, but we've also bred in a few things that we don't want. So purebred dogs inherently have some risk of inherited eye disease. Cataracts is an interesting one because very few genes have been implicated in cataracts in dogs. So just a couple of different genes. So Australian Shepherds, Boston Terriers would be off the top of my head, two breeds that get inherited cataracts. By far the most common cause of cataracts in dogs that we see clinically that are meaningful to the dog is diabetes mellitus. So in humans, actually diabetes does not cause to the same extent clinically significant cataract. But in dogs, if your dog gets diabetes, they have a close to 90% chance of getting cataracts. And those cataracts are complete and vision impacting. So, and we see diabetes in high frequency. So we see plenty of diabetes in our dog population. So I think it's just, if you get a newly diagnosis of diabetes, just be mindful of being aware that could then lead to cataracts. I think we see a lot of cataracts in dogs as they age. Those cataracts we do not currently deem as clinically relevant because they're so tiny. But of course, they're not tested in the way that allows us to say how meaningful those cataracts are. So I don't know if, as we get better ways of testing vision, especially if you have a sporting or a working dog that needs its vision, so a retriever or a police dog that's chasing criminals, we'd certainly want that dog to still be able to retain its good quality vision as long as possible because of the amount of time and money that goes into training those service dogs. So I think this has potential impact as we kind of get into quality vision testing. Question over.
So typically dogs seem to be like very active, right? So what typically causes diabetes in them? Is it like a lifestyle, the caloric?
It's typically type 2 diabetes, so it's insulin resistance. It's the type that's more common in older people, if I'm understanding correctly. Here's where my ophtho knowledge and regular life knowledge. Ali's, my resident, is nodding. So yes, so it's not really lifestyle. It seems to be a spontaneous event that happens. I think the healthier we keep our dogs, I would say, is the better. But I don't know that we know for sure that there are actual truly proactive things we can do to protect them from diabetes. It seems to be there are some breeds perhaps that are a bit more susceptible, but certainly it's also a spontaneous disease. Good question. All right, I should pass it on to our esteemed colleague.